Welcome to another video on my Arduino Mega2560 as well as with my Arduino Uno connected to breadboards with electronics and fischertechnik. Fischertechnik is controlled by pulse width modulation as well as the electronics, and boards are interconnected by serial peripheral interface and I2C, and that is what the focus is on mainly. The I2C does work, as it has been proven in the previous episodes. The only problem is that I try to establish pulse width modulation with part of the electronics on this breadboard, because it is handled in the same function. So the I2C is being called from here to do something, to send a text back, and at the same time address an LED here. And right now, if you look at it, it hardly works. Right now it doesn't work. But if I look, well, the LED doesn't do anything right now, but if I look at the oscilloscope, then I can see it does work. The upper two lines, this one and this one, are for the I2C. This one is pulse width modulation. Now, if you look at this band, it is currently set to 100 milliseconds, and that line is the I2C. So let me change the time base, and right now it's set to 200 microseconds, and you can clearly see that it is much longer off than on. And the pulse width modulation is set to channel 3, which is this one. So now you can see how well it functions, and now it's completely off, and now it's on again, but this should be completely reverse. So that's a thing to worry about. Now let me even reduce the time base further and see whatever happens to the I2C, because something should happen. And that doesn't, and that is very typical. Well, apart from that one line that you saw, because when I look at the screen, I do see results. So let's get back to the board and everything else. Another thing is that this motor doesn't work. Well, not effectively at least. This motor does work with some help, so I should be working on that as well. But first, timing. I tried to do some other timing process on the board. It doesn't work out yet, so that is where I'm headed next. Let's see how I can solve it. Right, so the question is now, for this particular wiring, not the orange one is SPI, serial peripheral interface, but this small piece of wiring is I2C, and here you can see that it definitely works. This is being received from this side. this is pulse notification, and this is I2C, but the signal is not really showing much, if anything at all. So, why would that be? I am not quite sure. It just works usually. Since it works, the wiring is okay. I don't need to check that. So let's go here for a timeout. I did define the timeout here, although I didn't assign anything to timeout. I didn't assign a value, and that may be a little problem. So if I first say, alright, what is timeout anyway? I think that is very valid. Idea. Print line timeout. If timeout is nothing, or 0 or whatever, then it is possible that it doesn't work. So I have screen working like last time. So let's first determine process numbers, which I have to kill. Alright. Now select the proper board and the proper port. Upload. And this one, and go again. So now I'm very curious what the timeout value will be. 0. Timeout is 0. I don't mind. However, what is millis? That's another one. But millis is a function, and this is making me wonder. Oh, really? Timeout's 8000. So it does work. But what else does it do? And then 12,000. What else does it do but this? That's a big question. Does it even pause for some reason? I think I should change this, because right now it's not clear which one it is doing. So let's copy this here and say, right, timeout 1000 and timeout 3000 to indicate which one it is doing or just did. So once again, 3708 and 3709. If this is indeed the recommended way to do the I2C timeout for the frontal modulation, okay, no, it's not I2C, it is an I2C request event, but I'm dealing with pulse modulation here. So, will this work out anyway? Timeout 1000, timeout 3000. Okay, apparently that is working. However, despite the fact that apparently millis is working and there's a timeout of 1000 and 3000 added, there's no delay in it. And the delay is clearly a lapse in time. So this is rather strange. So I need to find out how to apply it correctly, apparently. Let's find out. Alright, trying a different way using this example. And I do, of course, a little bit different. This I do the same. Then I use two timeouts, 1000 and 3000. And then if millis minus timer is larger than timeout 1, which is 1000, timer plus is timeout 1. So I am very curious if this will now really delay for 1 second. I'm very curious on it. If it doesn't work, I have to scratch my idea on, let's go to that, this one. Then I have to scratch this idea, but I hope it won't be necessary. So, let's once again kill screen 1, 73 and 3774. That's not 7 too much. And then kill. Yep. Then yeah. Well, here has to be here. Upload. Timer was not declared. Really? How about that one? So this is being in the setup, this is in the loop. This is the declaration. Setup. Oh wait. How about doing it in the setup? Is this in the setup? Yes, it is very clearly in the setup. Except this is not really in the loop. So, okay, let me comment it out for now. Try again. No kidding. Timer is not being accepted as. Why is that? Because it's not in loop. It is being done in setup, or how wrong can I be? Unsigned wrong timer. Ah, oh, wait, mistake. Unsigned wrong timer. And probably also unsigned wrong time. Also, yeah, right. So timeout 1 and timeout 2. And this covers this one, and the rest as well, although it didn't fail on this one, neither on this one, it just failed on the timer. Okay, let's see how this ends up. Pretty good apparently. Well, in declaration that is. Why is the programmer not responding? Okay, now it's done. So, go. Oh dear. That doesn't look like a timeout. Let's get the camera. Because with the timeout, I should get this one the way I like it, which actually would be high for 1 second and low for 3 seconds. Oh, wait a minute. High for 1 second, low for how much? 3 seconds. Oh, wait. If I regard this, it does exactly what it should do. Okay. High and then wait for 1 second and low for 1 second. Let's turn this around. That it is low. But what is it doing anyway? It is coming from pin 6, pin 5, yes. So it is high indeed. And if I want to turn this signal around, well, let's just do it. Okay, 0 here and 255 here. Let's just do it. See if it is indeed turned around. So by now it is 55.11 and 55.12. Go. Once again, go. Done. Now I'm very curious what will happen. Start and camera. can't say I am much impressed. I'm not impressed that much, unfortunately. I can regard this as low. Although, yeah, now it is low for 1 second. If I regard this as low, then it is not 1 second, it's way longer. And this is high and done. So, if this is supposed to work, please tell me how. Okay, so now that I have my doubts on working of this, there is one other timeout that I have used or am using. This one. It seems not to work at all, and this is in the loop. So what I am going to do is introduce another one. Which is of course timeout 3, which, well, yeah, with length should it have 5, okay, 5 seconds it will be. And then of course timeout 3 has to be that. That's good. Then this is going to be copied. Here. And then of course 3, 5. So now I'm really curious if there will be a 5 seconds timeout. If this is not working, I have no clue what to do. But first, 5591 and 5592. Here, okay, go, done, nicely done. So, start and come on. Is it just me, or is this really going like hell? Hold on, I can't even read this anymore. Oh, stop. I can't read this anymore. Wait a second. I am seriously taking this out and redo delay. This is really getting crazy. I can't read this. 872 5873. Alright. Done. Alright. So my conclusion is that this delay actually somehow does work. It's not 5 seconds. That's impossible. 1, 2, 3, 4, 5. It is 5 seconds. But not that one. 1, no. Okay, time. 1, 2, 3, 4, 5. 1, 2, 3, 4. No. Okay. 1. This is not a regular delay. This is no delay, hardly any. Delay 5000 is a delay. So apparently delay does work here. But what is going on here then? What is this? That's a very nice question. Very good question. And unfortunately I don't know yet. I have to test further and find this once again short. So this has to be taken out. Oops. So, end of this episode. Some curious findings. A pulse width modulation that despite attempts is not changing in timing. Then a different way of timing is not working out at all. With that, 3 different intervals and no difference. Even worse, when I take out a non-recommended instruction called delay with 5000 whatever milliseconds or so. The output on the Uno side, that side, not this one, that one, becomes unreadable because it goes fast like lightning. And that makes it completely, totally unreadable. Which way to go? I have no clue. Unfortunately, this is well, some kind of working, but mostly not, which is also strange. This is working strangely because it's not working the way it should via the transistor. Then this one works now because I added, I gave it some help, and this one, well, this one just doesn't want to run. And that's about it. Thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment if you like, much appreciated. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. Please donate to show your support. More information on how to donate at the start of the video and on my website. And you can also choose to become a patron and have your name mentioned as a supporter. More information on my website and on my Patreon site. Thank you for watching. Bye bye.